there are two problems in the screen. On the screen, we'll start with the first problem. The problem is like this. When the fundamental frequency of a wire is increased by 6%, its tension is increased by 44% at constant length. Let us try to understand. When there is a stretched string between two rigid supports, there is a formation of a transverse wave like this. But here he is saying that the fundamental frequency. So I will draw a diagram of that fundamental frequency itself. Fundamental frequency means there is only one segment of vibration. It is disturbed at the middle. Therefore, at the middle there is a formation of an antinode. The wave comes back. This is a fundamental mode of vibration, where the equation for the frequency of the stretched string is 1 by 2L into root of tension by linear density. We have derived this equation so many times. Now what he is saying is, when the fundamental frequency changes, tension is also changing under a constant length. So taking that into consideration, I can write N is directly proportional to square root of tension, as length and linear density are kept constant. So I can write N1 by N2 is root of T1 by T2. If I call N1 is N, N2 has to be written as N plus 6, because he said fundamental frequency is increased by 6 Hz. Root of, if I call T1 as D, T2 as D plus 44% of that, T increased by 44%. So if I try to simplify this, N by N plus 6 is equal to square root of tension by tension plus 44% means, to convert any percent into number, I shall divide with 100. That is T by T plus 44 by 100 is 0.44 times of T. So numerator is T, denominator is T plus 0.44. T means 1 T. That is 1.44 times of T. T and T can be cancelled. Square root of 1 by 1.44. Square root of 1 is 1. Square root of 1.44 is 1.2. Because 12 12s are 144. You know that, right? It's a simple thing. So N by N plus 6 is 1 by 1.2. So if you cross multiply that, 1.2 times of N equal to N plus 6. 1.2 times of minus N equal to 6. That is, N if I take common, 1.2 minus 1 is equal to 6. So N of 1.2 minus 1 is 0.2 equal to 6. So N equal to 6 by 0.2. That is 6 by 0.2 means 2 by 10. That is 60 by 2. That equal to 30 Hz. So the fundamental frequency of that case is actually 30 Hz. I have used a very simple formula, laws of stretched strings, to derive it. That's the first part of the problem, but there is another problem. I will now try to solve the other part of the problem. What is that other problem? Find the change in the fundamental frequency when the length of the wire is increased by 20% under the same tension. I will use the same rule again. Now linear density is constant, tension is constant, length and frequency are related to each other. So what's the relation between them? As we know well, we can write the relation as N is inversely proportional to L, because tension is kept constant. So N1 by N2 equal to L2 by L1. He said when the length is increased by 20%, so L2 is L1, similarly 20% of L1 like the previous case. So L1 20% means 20 by 100 of L1 by L1. 20 by 100 is 0.20 L1 by L1. So if I take L1 common, 1 plus 0.20 by L1. L1 cancels. 1 plus 0.20 is 1.2 by 1 equal to N1 by N2. Yeah, we have found that N1 by N2 is 1.2 by 1. That implies when you cross multiply, N2 is N1 by 1.2. We have found N1 already as 30 Hz. So 30 by 1.2, that is 25 Hz. So frequency is reduced from 30 to 25 Hz. So the change in frequency is 5 Hz. That's what we are intended to solve in this video. Thank you for watching.